Hello everyone. In this video, I'm going to go over some homework questions about probability of events that use the words given and. So here is our first section. We have a table that shows the number of students enrolled at SU during spring 2026. And we have their gender and whether they are a first-gen student or not. First-gen means their parents did not complete college. So use the information in the table above to find the following probabilities for the experiment of selecting one student at random. Okay, so what is the probability that if we randomly select from all 2,089 students that we get a female student? So this is going to be a fraction where the top is the number of ways to get a female student, and the bottom is going to be number of ways to do anything, just to perform the experiment and get any outcome. So number of ways to get any student. So all the outcomes of the experiment go on the bottom there. So there are 1,156 women. So that's the number of ways to get a woman. And then any student, it's all of the students. That's how many ways to get any outcome to the experiment. So this is the probability right here. You could plug it in a calculator and turn it into a percentage if you wanted to, but I haven't told you to do it, so I would just leave it like this. Next, probability of selecting a female first-gen student. So female first-gen students, there are 387 of them, and we're still just selecting one student from the whole student body. So that will be out of 2,089. Okay, now it gets a little bit different because in these questions we have given that something. So when you see the words given that something, now you're not selecting from the whole pool of students, but you're selecting from a smaller pool. So this is probability of selecting a female student given that the student is first gen. So if we say given that the student is first gen, it means we're certain that we're going to get a first gen student. We're only interested in picking from the first gen students. So if you know that you're going to get a first gen student, what's the probability then of getting a female student? So in this case, we're only looking at the first gen students, and that is going to be that smaller pool that we're drawing out of. So the probability here, if we write it as a fraction, this is number of ways to get a female student given they are first gen, and then divided by number of ways to get a first gen student. So it's a smaller pool. So the total first gen students is 630. So that's our pool, given pool. And then the number of ways to get a woman given that they are first gen is, the female first gen students, 387. That's going to go on the top. Now the other way around, probability of selecting a first gen student given that they are female. So now the pool that we're selecting out of is the female students, and we're going to see how many out of that pool are first gen. So here the fraction that we want is number of ways to get a female first gen student given, well, wait a minute, let me write this the other way around. Number of ways to get a first gen student given they are female. And on the bottom, number of ways to get a female student. So interestingly enough, the top is going to be the same number in both cases. So if you know that you're only looking at female students, the number of them that are first gen is the same number we saw before, 387. But now the pool is different. So on the bottom, we want all of the female students, which is 1156. Okay, so we get two different answers here. So it does in fact matter which event is the one that you're getting the probability of, and then which one is the given event. We cannot swap these two things and get the same answer. All right, the next part, consider the experiment of selecting one random student who was enrolled at SU during spring 26. So it's the same class of students, but we're looking at different events this time. We have varsity athletes, Greek organizations, meaning frats and sororities, and then campus job. So we have a bunch of given probabilities here that get a bit complicated. So what is the probability that the student is a varsity athlete and is in a Greek org? So when you want the probability of multiple events happening at the same time, so probability of varsity and Greek, one way to calculate this is to do the probability of the first event, varsity, and then multiply by the probability of the second event, given the first event. And which event is first or second doesn't really matter. Varsity and Greek is the same as Greek and varsity. If you're that student that's in both, I mean, you could describe yourself either way. You're a varsity student and you're in a Greek org, or you're in a Greek org and you're a varsity student. So which event we calculate the probability of first doesn't really matter. As long as we can find the numbers in the table, then either way should be fine. So let's see. Probability they are a varsity athlete is the first row of the table, so that's 26.5%. Oops, over here. And then the second probability, Greek given varsity, that's this row. Probability the student is in a Greek organization given they are a varsity athlete is 9%. So basically 9% of the varsity athletes are in a Greek org. How do you multiply percentages? You have to put these into decimal form. So this will be 0.09. Multiply them in decimal form. So 0.265 times 0.09. And we get 0.02385, which I can then convert back to a percentage as 2.385%. I'm okay if you guys want to round to the first decimal place, that's fine with me. This would be 2.4%. I haven't really given you a general rule of thumb for decimal places, so I'll let you know how many to use on a quiz or a test. Okay, number 6 is a varsity athlete and has a campus job. So probability of varsity and campus job, we can do probability of varsity times probability of campus job given varsity. Okay, so probability of varsity we already know is 26.5. Probability of campus job given they are a varsity athlete, that is this row in the table, 24.9%. So you see what you're doing here is first you're narrowing the SU students down to just the varsity athletes with that first percentage, and then you're taking a percentage of that percentage. Then you're taking the percentage of that varsity group that also have campus jobs. And so by doing that, you get the students that are in both groups. Okay, so again, we have to multiply in decimal form. .265 times 0.249. When you have the calculator open, you can hit Control-C and then it copies the answer like that. So 6.6% approximately. Okay, number 3 is in a Greek org and has a campus job. So I'm going to just type the second part of the probability equation, which is these two things multiplied together. So this will be probability of Greek times probability of campus job given Greek. So probability of Greek is up here, 16.5%. Okay, and then within those Greek students, the probability they have a campus job is the second to last row, 49.7%. So quite a bit higher than the regular percentage of all students having a campus job, 49.7%. Multiply these in decimal form. Should be about 8%. I think it's about half of that 15, or about half of that 16%. Let's see exactly. Yeah, 8.2% approximately. Okay, now this one is a little bit different. So probability that the student is in a Greek org given they have a campus job. So the hint here is to use the equation below, fill in the two pieces you know, and then solve for the piece you want to know. So is in a Greek org, given they have a campus job. So this is not one of the pieces of information that's in the table. We have probability they're in a Greek org, given they're a varsity athlete, but we don't have given they have a campus job. But we can work this out using the logic that the probability of being in a Greek org and having a campus job is the same as probability of campus job times probability they are in a Greek org given they have a campus job. So this is going back to that fact that the two events that you want to calculate the probability of both of them happening, it doesn't matter which one you list first. You could say probability of Greek and campus job, or you could say probability of campus job and Greek. So if you say it the other way around, probability of campus job and Greek, then you can do probability of campus job times probability of Greek given campus job. And this is the actual part right here. That's the part that we're trying to calculate. And we can do it by knowing these other two parts and then solving for it. So we do actually know this thing already, probability of Greek and campus job, because that was number 7. And we do know this probability, campus job, because that's in the table. So that means if we know 2 parts, we can solve for the 3rd part. Okay, so I'm going to put it in this form, I think, with the decimals. So that's the left side of the equation. And then probability of campus job is 39.4% overall. So like that. And then this is the thing we want to solve for. My color coding has, there we go. Okay, so to solve this equation, we just need to divide both sides by this 0.394. So I'll do that. Let me just copy this. And then cut this part, divide, put it over here. Okay, so that's all we need to do. I'll just get the calculator out and do it. So actually I already have the calculation right here. This is 0.165 times 0.497, and then I'm going to divide that by 0.394, and I get 0.208. So this is approximately, whoa, that's really long. I'm just going to round off right there. So approximately 20.8%. So this is a kind of like a sneaky way that you can calculate given probabilities, even when you don't already know them, by filling in parts of this equation and then solving for them. It's pretty cool. Okay, well, it's cool if you're a math nerd like me anyway. All right, so back to regular questions. Number 9, is a varsity athlete and in a Greek org and has a campus job. So we're going to do this the same way we do 2 events. We're just going to start with the first one, so probability of varsity. Then we go to the next one, probability of Greek given varsity. And then for the third one, probability of campus job. And you do given for all the previous things. So given varsity, and Greek. So basically you're narrowing down the pool 3 times. First you narrow down all the SU students to just the varsity ones. So you see what percentage that is. And then you take a percentage of that percentage that are Greek. And then you take a percentage of that percentage that have a campus job. So each time you have the given part here is telling you what pool to take the percentage out of. So when you do your second probability here, you want the percentages that are Greek within that varsity pool. So that's why you have this given varsity part. Excuse me. Pardon my alarm. I live my life by alarms. And then once you've found the percentage of all SU students that are varsity and Greek, you're then narrowing down that pool again to just see what percentage of them have a campus job. Okay, so anyway, we have the first 2 numbers. Let's see, varsity, 26.5%. Greek given varsity is here, 9%, 9.0%. And then the third number, campus job given varsity and Greek, is the last row, 50%, exactly 50.0%. Okay, so we just multiply these three numbers together. I'm going to skip the part where I put it in decimal form, and I'll just assume that you guys know how to multiply percentages. So 0.265 times 0.09 times 0.5. Okay, so it's a little more than 1%, it looks like. So that's approximately 1.2%. Should be pretty small because this is as you would imagine, this is a small number of students that are in all three things. I'm amazed anybody has time to do all three of those things. Looks like it's only about 1% of the students, so about 20, 21, 22, something like that students. Okay, for number 10 and 11, we're doing OR events. Make sure you notice this says OR right here, OR. So for OR, you can always do it by adding together the probability of each thing individually and then subtract the overlap. So probability that they are varsity and Greek in the same student. So we're going to add together probability of varsity, 26.5%, plus probability of Greek, 16.5%, minus probability of both. How do we get the probability that a student is varsity athlete and in a Greek org? That is the answer to number 5. Okay, so I'm going to copy my answer to number 5 and write it down here. Okay, so this right here is the answer to number 5. And I think we need to be like a little bit careful when typing this into the calculator. So 26, oh right, I have to do this in decimal form. Okay, so 0.265 plus 0.165 minus, and then I'm going to put parentheses here. Now, technically in the order of operations, multiplication should go first. So like theoretically, you don't need parentheses. But when I'm working on these 4-function calculators, sometimes they don't respect the order of operations very well. So I'm going to use parentheses right here anyway. 0.09, close parentheses, hit enter. Okay. So we're getting 40.6%, approximately 40.6%. So it should be an answer that is more than the individual probabilities of the two events, either one of them. So 40 is more than either one of those, and it should be either the same or less than the sum of those two. So the sum of 26 and 16 would be what, like 42, and 40 is less than that. So this is good. It seems like it could be the right answer. That's just like a little quick rule of thumb to check if you got the an answer that is in the right range. It's a way of checking your work. Okay, so next one, probability of Greek plus probability of campus job minus probability of both. And I think we also calculated this part that's going to be subtracted. Okay, I had to pause there for a second. Where was I? So probability of Greek is the second row in the table here, 16.5%. So we're going to do 16.5% plus probability of campus job just overall is 39.4%. So if there's no given, then it's the overall probability. And then minus probability of Greek and campus job. So that should be one of the answers we already calculated, probably. Let's see, Greek, yeah, that was number 7. So we'll take the answer from number 7, Greek and campus job. Okay, and let's put these in the calculator. So 0.165 plus 0.394 minus parentheses 0.165 times 0.497, close parentheses, hit enter, and we're getting 0.477 approximately. So approximately 47.7%, which should be more than the sum, or sorry, should be more than either of these two numbers here individually and less than or equal to their sum. Okay, the last section of this homework is the mystery boxes. Yay, everyone's favorite. Okay, so the mystery boxes. I have 20 mystery boxes. This is true. Each mystery box has 5 marbles, and each marble is black or white. This is all true information here. 1 marble at a time can be observed through a window in the corner of the box. So it is not possible to look at all 5 marbles. You can only look at 1 marble at a time. So there are 4 types of mystery boxes. Type A has 4 white and 1 black. Type B has 3 white and 2 black. Type C has 2 white and 3 black. And type D has 1 white and 4 black. So these are the only types that exist. And I have an equal number of boxes of each type. So 20 boxes in all. That means I have 5 of each of these types. So let's imagine that you are going to select a box at random, and then you're going to shake up the box and observe 1 marble. And we want to know the probability of these different events. What's the probability that you chose a box of type A? So this is pretty easy because there's only these 4 types, and I have an equal number of boxes of each type. So it's just a 1/4 probability of each type. Pretty straightforward, hopefully. So it's an equal probability for each type. And that's why it's 1 out of 4. Okay, now next, the probability that you see a white marble given that you chose a box of type A. So probability that you see a white marble given that you chose a box of type A. So the type A box has 4 white marbles and 1 black marble. So if you know that you're already holding that type of box, now what is your probability of seeing a white marble in that one glimpse that you're going to take through the corner of the box? Well, it's just 4 out of 5. So there's 4 white marbles out of 5 marbles. So that is the probability. Probability of white given type A is 4 out of 5. That's just the proportion of white marbles that are in the type A box. So now something a little bit more complex. The probability that you chose a box of type A and you see a white marble. So now we're going to use our formula for multiple events happening. So the probability that you get the type A box and see a white marble is the probability of choosing the type A box times the probability of seeing white given that you have the type A box. And these are the 2 answers that we just calculated up here. So the probability of getting the type A box is 1/4, and we're going to multiply that by the probability of the second event given the first event. So the probability of seeing white given that we have type A box is 4/5. So we could simplify this if we wanted to. It's 4/20, or you could cancel it down to 1/5. I think I'm going to write it as 4/20 simply for the reason that these are not all going to cancel out and I want to end up with a common denominator. So I'm just kind of thinking ahead there. Okay, so for 15, we're going to repeat these 3 answers here for the other 3 box types. So just do the same calculations, but for box type B, and then box type C, and then box type D. And all I really want to calculate is this last one, but I need the first 2 answers here to get this last one. Okay, so probability of getting a type B box. Actually, it's the same for all of these, isn't it? It's the probability of type B, type C, and type D are all the same. It's just 1/4 for each of them. So I can do that part. I can repeat number 12 quickly for the other box types. Number 13, now we're going to have some different answers. So probability of seeing the white marble given that you have the type B box. So there's 3 white marbles in that box, so that's going to be 3 out of 5. And now probability of seeing white given type C box. The type C box has 2 out of 5 that are white. This will be 2/5. And then finally, the type D box has 1 white marble, I believe. Yes, 1 white marble out of 5. Okay. And now that was repeating number 13 for all the different types of boxes. And now I want to repeat number 14 for all the 3 types of boxes. So the probability of type B and we see a white marble, so probability of getting type B and seeing a white marble is the probability of getting box type B times the probability of seeing the white marble given that we have box type B. So it's going to be like this. So this will be 1 times 3 is 3 over 4 times 5, which is 20. I'm going to write these all as out of 20 because actually I'm going to add them up in a minute. Next, the probability of getting the type C box and seeing the white marble, again, is the probability of getting the box type C times probability of seeing the white marble given that you have box type C, which is 2/5. So this is 2 out of 20. And then finally, probability of getting box type D and seeing the white marble is 1/4 out of 2/5. Oh, sorry, not 2/5. This will be 1/5. The type D box only has one white marble. Okay, so now the point of doing that was to make number 16 and 17 possible. So 16 and 17 here, these are harder than what I would put on a quiz, so you don't need to like study these super hard. But these are the most interesting questions on this homework, I would say. So if you have any interest in this at all, these are fun to look at. Okay, so what is the probability that you chose a box of any type and you see a white marble? So the hint here says the event chose a box of any type and see a white marble is the same as chose type A and see white, or chose type B and see white, or chose type C and see white, or chose type D and see white. So the event of getting any box and seeing the white marble can be broken down into these 4 different possible ways that it could happen. You can see the white marble with type B, or you can see the marble with type B, or type C, or type D. So once you realize that this event where you're trying to calculate the probability can be broken down into an OR event, that means you can apply the OR formula. And these 4 ways that the event can happen are mutually exclusive. You cannot choose more than one box type. We're only doing the experiment once. And the experiment is choosing a single box and then looking at a marble once. Okay, so probability of choose any box and see a white marble is the same as probability of type. So let me write it like this. Type A and see white plus probability of type B and see white plus probability of type C and see white plus probability of type D and see white. Okay, so these are the 4 ways that we can choose any box and see white. And we do not need to worry about subtracting any overlaps here because these are mutually exclusive events, so only one of them can happen. All right, and we have these 4 probabilities because we calculated them up here. So the very first one was number 14, and that was 4 out of 20, and then the other 3 are 3 out of 20, 2 out of 20, and 1 out of 20. Okay, so this is 4 out of 20 plus 3 out of 20. This is why I wanted to keep them all out of 20, so I can add them up on this step with the common denominator. Let's see, 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So actually 1/2. That's interesting. The probability of choosing any box and seeing white is exactly 1/2. So if you think about it, actually this should make sense because when you look at how many white and black marbles there are total, I have 5 boxes of each type. And the types go from 4 white, 1 black to 1 white, 4 black. So there is actually the same number of white and black marbles total overall in all of the 20 boxes. So there's 100 marbles in total. 50 of them are white and 50 of them are black. So yeah, actually it makes sense that this should come out to be 1/2. So 1/2 and 1/2 chance of seeing white versus black when you don't know what box was chosen, if it's just any box. Okay, so now this is the question that is actually what you would really want to calculate in this situation. So the point of the mystery box exercise is to like figure out how can you know what's in the box without being able to see what's in the box? Like, what is the right way to figure out which box you have and what are the proportions that are in the box without being able to just look in there? And it's not really about marbles and mystery boxes. I mean, it's about actual like sampling of real populations and looking at like, public health and medical treatments and stuff like that. So what is the probability that you chose a box of type A given that you see a white marble? So if you're only able to take one observation, just one observation, and you see white, how likely is it that you actually have the type A box? This is the type of information we'd like to be able to calculate. So if all you see is the white marble, what is your probability of having the type A box? So similarly to some other questions that we've seen, you can describe the event of choose type A and see white marble in either order. So choose type A and see white marble, or you can switch those two events around the word and describe it as see white marble and choose type A. And so if you swap those two words around, then we can calculate it as probability of the first event, seeing the white marble, times probability that you chose type A, given that you saw the white marble. And the second thing here is what we actually want to calculate. So one way to calculate it is to solve for it from this equation. And we now have enough information to do it because we know the probability that you choose box type A and see the white marble. That was number 14. And we know the probability of just seeing the white marble by itself without knowing the box type, because that's actually what we calculated in number 16. So the probability that you chose a box of any type and you see a white marble, that is the same as just the probability of seeing the white marble, because if you see the white marble, then you must have chosen a box of some type, right? You don't know what type. Okay, so we're going to fill in these two pieces of information. So the probability that you chose type A and you see the white marble, that is number 14, 4 out of 20. Okay, and then the probability that you see a white marble when you don't know what box type you chose, that's what we calculated in number 16, so that's 1/2. And then the thing that we want to solve for is this second part here, probability that you chose type A, given that you see a white marble. And very exciting now, we can actually calculate this. So to solve for the probability here, I'm going to multiply both sides by 2, or you can think of it as dividing by 1/2 if you want. So if I multiply both sides by 2, 2 times 4/20 equals, and then the 2 and the 1/2 are going to cancel each other out. So I'll just have that probability over there. So this is going to be 8/20, which I can reduce to, what's that, 2/5? By divide 8 by 4 and divide 20 by 4. So 40% probability that I have the type A box. If I take a random box, shake it up, and look at one marble and I see white, there's a 40% probability that I have the type A box. Even though I know there's 25% of that type of box, seeing the white marble one time is enough evidence to increase that likelihood to 40%. So this is pretty interesting. I hope you like it, and if not, these last two questions will not be on the quiz. And you should study, I think, number 1 through 15, and I'll see you again in class.